Welcome back, chemists. Let's do problem number 3 for our weak acids. All right. Number 3. A solution is prepared by adding zero point 0.1 moles of benzoic acid, and again, I give you the Ka, but you could have looked that up, with enough water to make 0.2 liters. What is the pH of the solution? All right, I'm going to do my fun little abbreviation. Oh, look, it's H-Ben. So my proton plus benzoate, my Ka is equal to the proton over n times Ben minus over H-Ben, and that equals 6.6 times 10 to the minus fifth. All right, what do I know? Let me see. A solution is made by adding 0.1 moles of benzoic with enough water. Okay, so I have to be in molarity. So 0.1 divided by 2. I'm going to do that little calculation right here. Should put it in half, so it should be 0.0500 molar. It doesn't say I added anything, so those are zeros, x, x. Okay. What is the pH of the solution is what I'm looking for. And from this ice table, I don't have a way to find x, so I'm going to have to plug it in to my equilibrium expression, which luckily I do know. So 6.6 times 10 to the minus fifth is equal to x squared over 0.050 minus x. I'm going to use my assumption. X is going to be 6.6 times 10 to the minus fifth times the 0.05, and then take the square root of that. And the answer is 1.8 times 10 to the minus third. I'm going to do it again just to be sure. Yep, 1.8 times 10 to the minus third. And I'm going to check it. Make sure my assumption was valid. And yes, it is less than or equal to 5, and it is above a magnitude of 10 to the minus 6, so those are both okay. So I'm allowed to use that number. All right, let's plug that in. X is 1.8 times 10 to the minus 3, and 1.8 times 10 to the minus 3. Don't forget your units. Now, some problems eventually are going to be not just X'd, so don't just get comfortable plugging that in. The only reason I'm doing that is because the proton concentration and the benzoate concentration are X in this case. And then 0.050 minus 1, and that equals 0.0482, and I'm allowed to keep 3 after. No, I'm allowed to keep 4 after, 0.0500. I'm allowed to keep all of them, so 0.0482. Ah, nice. Guess what? I didn't answer the question yet. I filled out the table, but what I really wanted to know was what is the pH? So the last thing, I'm going to plug it in to the negative log calculation, and it's 1.8 times 10 to the minus 3. And 2.74. Double check. Yep. And was I expecting an acidic pH? Yes, because this was a weak acid. And there is another example that's not acetic acid. Until next time, jolly out.